Hello, in this video, we will learn about orthographic projection in engineering drawing. Before learning orthographic projection, one must understand the significance of drawing in engineering. The reason is, or the reason why we are using engineering drawing is, we cannot describe components or products using spoken languages like Tamil, English, Hindi, etc. But the question now is why we need to describe a component or a product. The answer is to convey our design ideas and for manufacturing. As a designer, one needs to communicate his ideas to others. Similarly, in order to manufacture the component designed, the details must be communicated to the worker in the factory or the shop floor. That's why we learn engineering drawing. Suppose if the component is a cylinder, we can easily understand it has got a diameter and length or height. If it is a cube, it's a simple geometry or a simple primitive. A cube has 6 faces. All the sides are equal. We can easily understand. But if the component is like this, or if it is like this, you cannot define in a word or two like cylinder, cube, prism, etc. Hence, component like these cannot be described in spoken languages. Therefore, drawing is imperative in engineering. What we see on the screen is a pictorial drawing, or it is called an isometric drawing. Using this, one can easily understand the component or the product. So these types of pictorial or isometric drawing are used to explain the concepts. The drawback in this drawing is all the details cannot be given. Also, it is very difficult to draw. Therefore, we go for another drawing like this. So this drawing represents the first component and this drawing represents the second component. So what are these drawings called? These drawings are called orthographic projection. Orthographic projection is a two-dimensional representation of a 3D object. It gives complete details about the product or the component. For manufacturing, we generally use orthographic projection. Pictorial drawing or isometric drawing is substituted or it is given along with orthographic projection for easy understanding of the product. Now we will learn about what is projection. We are about to study orthographic projection. But what is projection? It's nothing but presentation of an image on a surface. Image of what? It's an image of an object or a product or a component. From optics, we all know for projection we need a screen. And of course, we need an object. We need a light source. When the light source is switched on, light rays will be focused onto the screen, and in between the object is present, and hence the image of the object will be seen on the screen like this. So in projection, we are interested only in this image. If you apply this technique to engineering drawing, we have certain terms. So in engineering drawing, also called as engineering graphics, the screen is called a plane of projection. Light source is replaced by observer. Observer is a person. He is going to imagine how the image will be corresponding to a particular object on the screen. And the image is called projection or projected view. In engineering drawing, we assume two planes of projection called vertical plane and horizontal plane, abbreviated as VP and HP, in order to obtain the image. Remember, earlier we discussed the screen to obtain the image of an object is called as plane of projection in engineering drawing. The two planes VP and HP are mutually perpendicular. For our convenience, we divide the space into four quadrants: 1, 2, 3, 4. How can we represent or denote an object that is present in quadrant 1 like this? So this object is represented by the words in front of VP and above HP. Suppose if the object is present in the second quadrant, then we say the object is behind VP and above HP. In order to obtain an image or the projected view on the vertical plane, the observer needs to stand in front of VP and above HP. It is imagined the light rays emanate from the observer, pass through the object, and an image is obtained on the vertical plane. What we observe is the light rays are diverging. Compare now the size of the image and the object. Image is greater in size than the object, that is because of divergent rays. Since the image or the projected view, as we call it in engineering graphics, is obtained by looking from the front, this image or view is called front view or elevation. In other words, front view or elevation is obtained in VP. Okay, after discussing the necessity for engineering drawing and learning about projection, it's time to discuss our topic, orthographic projection. So what is the difference between projection and orthographic projection? As usual, we have two mutually perpendicular planes of projections, VP and HP, and the object is present in first quadrant. The observer is standing in front of the vertical plane and above the horizontal plane. Light rays emanate from the observer's eye, pierces through the object, and an image is formed on the vertical plane. What is the difference? You can easily observe from the drawing the light rays are parallel to each other. At the same time, all the light rays are perpendicular to the plane of projection. Here it is vertical plane. Therefore, the advantage is we get an image whose size is equal to the size of the object. Image size is equal to the object size because the light rays are assumed to be parallel to each other and perpendicular to the planes of projection, plane of projection. Ortho means perpendicular. Therefore, the image or the view obtained by imagining light rays that are parallel to each other and perpendicular to the plane of projection is called orthographic projection. We get true size and shape if the object is parallel to the plane of projection. The biggest advantage is image size or the view size, that is the projected view size, is equal to the object size. What is the meaning of that? You know the geometry of this object. It's a rectangular prism. It has got length, height, and width or thickness. If you look at the image, we are able to see the length, also the height of the object. What about the third dimension, the width or the thickness of the object? In the image, we cannot say the third dimension because image, when you project on a screen, we get only 2D image. The thickness is not visible in the front view or in the image because a thickness line is perpendicular to the plane of projection. It is perpendicular to the plane of projection. Therefore, we are unable to see the thickness. To show all the dimensions in orthographic projection, we need two or more views. Two or more views are needed to completely define the object in orthographic projection. From the front view, we are able to see only the length and the height. To know what is the thickness, we need one more view at least. What is that view? So the image already obtained on the vertical plane is front view. And what is the second view that is needed to represent the thickness of the object in orthographic projection? To represent the thickness of the object in first quadrant, the observer needs to look from the top of the object, but his position is in front of VP and above HP. Looking from the top, we are going to project the object onto the horizontal plane. Light rays from observer's eye are parallel to each other and perpendicular to the horizontal plane of projection. The image is like this. The light rays are parallel and perpendicular to HP. from the image we can know what is the length of the object and what is the thickness of the object. Here, the height of the object is suppressed in the image because the height line, that is this vertical line, is perpendicular to the horizontal plane. The image or the view obtained by looking from the top of the object is called as top view or plan, and it is obtained in the horizontal plane. So we have two views. One is the front view obtained in the vertical plane by looking from the front of the object. The other one is the top view or the plan obtained by looking from the top of the object and obtained on the horizontal plane. If you are able to combine these two views, then the complete detail about the object is obtained. The question now is how to draw the front view and top view in a drawing sheet or simply a paper. So we have the two mutually perpendicular planes of projection. The object is here. By looking from the front, we obtain front view in the vertical plane and obtain the top view on the horizontal plane by looking from the top. In order to represent these two views in a drawing sheet, we assume the horizontal plane of projection is rotated in clockwise direction through 90 degrees. To represent the concept of rotation, the object and the views are removed, only the mutually perpendicular planes are shown. The horizontal plane is rotated through 90 degrees in clockwise direction like this. After rotation, the horizontal plane will coincide with the vertical plane like this. Therefore, by rotating the horizontal plane through 90 degrees in clockwise direction, we made the two planes of projections VP and HP coincide with each other, and it looks like a sheet of paper. In order to differentiate the vertical plane and the horizontal plane, we make use of the line of intersection. Observe the coincided planes and notice the horizontal plane represented in blue color is directly below the vertical plane. Now, once again, the object, front view, top view are shown. If you rotate and remove the object, the front view and the top view will look like this. In a drawing sheet or a piece of paper, we can draw these two views easily. How? Before that, notice the top view is directly below the front view because the horizontal plane is directly below the vertical plane. Now consider a drawing sheet or a piece of paper. In order to distinguish vertical plane and horizontal plane in this drawing sheet, we make use of the line of intersection. How it is used? So the line of intersection is just drawn on the drawing sheet arbitrarily or at any convenient position. Just a horizontal line, and name this as XY. In engineering graphics, XY line means reference line. A reference line is nothing but the line of intersection of vertical and horizontal planes. In the drawing sheet, the space above the XY line represents the vertical plane and the space below the XY line represents the horizontal plane. The front view is drawn above the XY line like this, and directly below that the top view is drawn like this. So these two views gives the complete detail about the object. The complete detail in the sense you can know or you can show the length of the component in the front view and also in the top view. You can show or measure the height of the component in the front view, and the thickness of the component is shown in the top view. So all the three dimensions are shown in this drawing. It has two parts. One is the front view, another one is top view. As we discussed earlier, orthographic projection is a two-dimensional drawing of a 3D object. The object in our example is a rectangular prism. Orthographic projection needs two or more views to completely define the object. Here we use front view and top view. One view is insufficient to completely define the object in orthographic projection. Hope you understand why engineering drawing is required. It is used to communicate with others, maybe to convey your ideas or give instruction in order to manufacture the component. Therefore, drawing is called language of engineers. Thank you.